Hello again, another video on determining equations. So just to remind about what that means. Determining means to figure out, that's not spelled right, determining, figure out what the equation is using detective work. And a reminder, y equals mx plus c, and what we're trying to figure out, can you find m and can you find c? If you can find those two things, you plug them into the equation and you're done. Okay, so that's what we're trying to do. The next situation that we'll look at, so I'll just go to a new screen. Next situation is this: when you know 2 points. That's it. Okay, when you know 2 points. In other words, you don't know m. You don't know what c is equal to. You don't know m, you don't know c. You just got 2 points. So it might be something like this, where you've got that. And let's just do this one right here. And let's say that you know this point up here and this point down here. And so let's just say that's 3 and 5, and this one will be sorry, I'm just trying to make it so that it works out nice. Let's make it negative 4 and negative 2. Okay, we'll just make it like that. So there are our 2 points, and we have to try to figure out what the equation of the line is. Now let's have a look at it. We don't know c. We don't know where it goes through this y-axis here. So there's the y-axis. We don't know that. So we can't even start. We don't even know the gradient. We're not told anything. So we're actually a long way from finding this answer out. What is m and what is c? Now, if you're good with your gradients, you'll know that we can actually find the gradient out here. So let's do that. Remember, if you will, the gradient is equal to y2 minus y1 over x2 minus x1. So we can use these 2 points to figure out what the gradient is. What is y2, y1? Again, it doesn't matter. You just choose this. So we'll choose this as x1, y1, and we'll choose these points down here as x2 and y2. Alright, so now let's plug those values in. What's y2? y2 is this value down here, negative 2. So negative 2 minus. What is y1? y1 is 5. Good. x2 is this value down here, negative 4. Oops. Negative 4. And x1 is this value up here, 3. So we minus 3. Good. This is equal to negative 2 minus 5 is negative 7. And negative 4 minus 3 is also negative 7. Gee, that is fortunate. Negative 7 divided by negative 7 is 1. Okay, lucky. We get something nice there. The gradient is equal to 1. So that's really good. We have the gradient's equal to 1. And what is good to do at this point is to put that into our equation. So remember, y is equal to mx plus c. And so what we've got is y equals mx plus c. Means y equals m's equal to 1. So it's 1x plus c. We know that. And this is a really good starting point. We've found what m's equal to. Now we just have to figure out what c is equal to. So the next place here, and I'm just going to rewrite that, it's just annoying me. 1x is just x. Okay, so just x plus c. Alright, now we just need to figure out what c is equal to. Now, this is probably the tricky bit and where you need to concentrate. This is the equation of the line. Y equals x plus c is the equation of the line. And each point on that line satisfies this equation. It makes this equation true. And so what that means is that if you get this point like 3, 5, the x value and the y value, this point must satisfy this equation. And so what we can do is we can actually substitute the point 3, 5 into our equation here, into y equals x plus c. Okay? put that x value in, put that y value into this equation, and that will tell us what c is equal to, and I'll show you what I mean. So therefore, this is saying that y, the y value, what is the y value? That's the y value, and that's your x value. So this means that 5 is equal to the x value, 3, plus c. We still don't know what c is. But can you see, by putting in this known point, we know that that point's on the line, so we know that that point satisfies this equation. So that means that we just need to solve this for c. How do we solve that for c? Well, c will be equal to, if we want to get rid of this positive 3, we move it to the other side, over here, and that becomes negative 3. So c equals 5 minus 3, which is equal to 2. So c is equal to 2. Fantastic. Is this important? Yes. Now that we have c, we've found m already up here. M is up there, m is 1. C is equal to 2. Therefore, the equation of the line is y equals mx, I'll just write it, mx plus c, which means y equals mx, so 1x plus 2. That is the equation of the line. Every point on this line will satisfy this equation, where the y value will be the x value plus 2. And so that is your example of what to do when you just know 2 points. Now I'll just check my time and see whether I've got time. I've got time to show you one more example, and the next one I'll do is when you know m, when you know the gradient. But not the y-intercept. So let's look at this situation. You know the gradient, but not the y-intercept. Here's my example here. So an example, find the equation of the linear graph with gradient, sorry about the writing, it's a bit slow and boring, isn't it? With gradient of negative 3. And which goes through the point. Goes through the point, let's just say 2 and 5. Let's just do that. That will work out nice. We'll see how it goes. 2, 5. Cool. That's not going to work out nice, just give me a second. Cool, let's just do that one here. Fantastic, so we're given the gradient, negative 3. We've got a point here, but we don't know what the y-intercept is. Okay, so let's just write down what we know. Remember, we're trying to find m and c. In here, we've been told the gradient, so there's our m. Awesome. But we've also got this point. This gives us some information. And we're going to have x1 and y1 here, and a value of x and a value of y. So let's write down our equation so far. We know that y equals mx plus c. Therefore, y equals, we've got this value of, we know what m's equal to. M is equal to negative 3. So we can write our equation down like that. Now, this is our equation. This point is on the line. Please understand this. This point is on the line. So that means this point must satisfy this equation. This equation must be true if this point is on the line. And so what that means is we substitute it in. So substitute 2, 9 into the equation. Alright, so we'll substitute that in. Right, remember this is the x value and this is the y value. So the y value is 9 is equal to negative 3x. So negative 3 times by the x value is 2, plus c. We still don't know what c is equal to, but this will help us solve it. Okay, so here we go. So I'll solve this bit. So I'll just simplify it. 9 equals negative 3 times 2, negative 6 plus c. Therefore, C equals, I'll move this negative C to the other side of the equation because I want to know what C is equal to. C is equal to 9 plus 6, which is 15. So in this case, C is equal to 15. Great. Therefore, what is my equation? My equation is Y equals mx plus our C value, which is, I'll just write C. Therefore, put it in blue. My final equation, Y equals, the m was negative 3, so negative 3x plus your value of C, which is 15. That is the equation of the line that satisfies that. And that is determining equations. It takes a bit of detective work. Figure out what the gradient is, figure out what the y-intercept is, use all your different sort of tools that you can to be able to figure it out. It can be a bit tricky. Just do as many problems as you can to get used to that particular skill. Enjoy.